Welcome to this explainer on Python Programming Foundations. If you've ever looked at a screen full of code and felt completely intimidated, we're going to change that right now. We're reframing Python today. It is not some impenetrable wall of jargon. Actually, it's a highly logical, incredibly empowering toolkit. Think of it like a set of digital building blocks that you can use to create, well, pretty much anything you can imagine.
But first, we gotta ask, why is Python literally everywhere right now? From running those complex algorithms at Netflix to powering the latest AI breakthroughs, dynamic web development, and heavy-duty data science, Python is the driving force. It is, hands down, the most versatile tool in the modern tech landscape. Plus, it boasts this massive supportive community, seamless cross-platform compatibility, and an open-source ethos that just keeps it constantly evolving.
Okay, let's dive right into this. Here is our progressive building blocks roadmap for today. We'll start with a quick welcome to Python, then move to our nouns in variables and data types. After that, we'll add some verbs with operators in action, establish our coding grammar in directing the control flow, and finally, we'll learn how to have a two-way conversation in user inputs and casting.
All right, part one. Welcome to Python, the Foundation. Created by Guido van Rossum way back in 1991, Python is a high-level, general-purpose language that's famous for its incredibly readable, clean syntax.
Now, as you explore Python, you're definitely going to hear about different versions, but we're focusing exclusively on Python 3 today, and here's why. Python 2, it's older, the syntax is clunkier, and frankly, it is completely unsupported now. Python 3 is the modern standard. It simplifies things so much. For instance, in the old version, printing text was a whole statement, but in Python 3, print is just a straightforward, easy-to-use function with parentheses. It is absolutely the path forward. So, to truly understand Python, let's demystify the so-called black box of how it actually works. When you write code, it isn't magic, right? It's just a beautifully logical, step-by-step process. First off, you write your human-readable code in a .py file. Second, the Python interpreter steps in and reads that code. Third, it converts your text into what's called bytecode. Fourth, the Python virtual machine, or PVM, executes that bytecode. And finally, boom, your output is displayed on screen. It's this fascinating, seamless translation from your brain directly to the machine.
And that brings us to section 2. Variables and data types, the nouns of code. Because before we can do anything, we need to know what things we're actually talking about.
That is exactly where variables come in. A variable is simply a name given to a memory location in your program, and we use it to store data. So the crucial point here is that Python is delightfully simple. Unlike a lot of other languages, you don't need a specific command to formally declare a variable's type before using it. You just assign a value to a name, and Python is smart enough to figure the rest out for you.
And what are those data types it's figuring out? Well, these are our raw materials. We've got the basics, like int for integers, float for decimal numbers, str for text strings, and bool for true or false booleans. But Python also gives us these amazing collections to work with. There are lists, which are ordered and changeable, tuples, which are ordered but unchangeable, dicts, or dictionaries for key-value pairs, and sets for unique items. These are literally the nouns you'll be using every single day.
Now, really quick, I need to plant a seed here. Here is a massive pitfall you have to watch out for. When you ask a user for input using the input function, Python always, and I mean always, returns a string. So even if someone types the number 5, Python sees it as the text character 5. If you're expecting to do math with that, it's going to cause bugs. Keep this in the back of your mind, because we're going to solve this exact problem a bit later.
Okay, moving right along to section 3. Operators in action, the verbs of code. Now that we have our nouns, we need some verbs to make them interact.
In Python, these verbs are called operators. An operator is just a symbol that performs an operation on one or more operands, meaning values. Simply put, operators are the foundational building blocks of expressions. They're exactly how we calculate, compare, and assign things.
Let's look at arithmetic operators first. You're definitely going to recognize the classics here: addition, subtraction, multiplication, and division. But I really want to highlight two incredibly useful tools. First, floor division, which uses 2 forward slashes, and modulus, which uses the percent sign. Floor division divides and gives you just the integer result. It basically chops off the decimal. Modulus is brilliant because it gives you the remainder of a division. Trust me, these are absolute lifesavers when you're doing things like organizing data or calculating time. We also have the exponent operator, utilizing two asterisks. If you write 10 asterisk asterisk 3, Python instantly does the heavy lifting and spits out 1,000. No sweat. It's kind of amazing how a tiny little symbol can execute such powerful math in just a fraction of a second.
But hey, operators aren't just for math. We use comparison operators like equal to, not equal to, greater than, and less than. And then we have logical operators, and, or, and not. These check if multiple conditions are true or false. Why does this matter? Well, because comparing data and establishing logic is exactly how we set up our programs to actually make decisions.
Which perfectly sets up Section 4, directing the control flow, grammar and logic. This is where our code goes from being just a fancy calculator to actually getting smart.
And this brilliantly illustrates how we manage those decisions, the if, elif, else ladder. Let's look at a mini narrative of a grading system. The program checks the first step. If the score is 95, print grade A. If that's not true, it steps down to elif the score is 80, print grade B. Then it steps down to 60 for a C. Finally, if literally none of those are true, the else block catches everything remaining, like a score of 40, and prints an F. The program is just logically checking each tier, step by step.
To really master this, there are a few golden rules you need to memorize. First, only the first true condition is executed. Once the program finds a match, it stops looking. The remaining blocks are entirely skipped. Also, that final else block, it's totally optional. You don't have to include it. And finally, you can put an if statement inside another if statement, which we call nesting. These rules are what make your programs incredibly smart and efficient.
All right, let's jump into our final section, user inputs and casting, the conversation. This is where we bring everything together and actually interact with our program. Remember that massive warning I gave you earlier? The one where any input from a user is automatically treated as a text string? Well, typecasting is our solution. Typecasting is simply the process of converting one data type into another to ensure your functions work properly.
There are two ways this happens. First is implicit typecasting. This is completely automatic. If you add an integer and a float together, Python is smart enough to just automatically convert the results into a float so you don't lose any data. But, sometimes Python doesn't automatically know what you want to do. That's when we use explicit typecasting. This is where you take the wheel, manually using specific functions to force the conversion.
Here is exactly how we do that. If we want a user's typed input to be treated as a math number, we literally wrap our input command inside an int function. So int, parenthesis, input, parenthesis. Now, if they type 25, it's saved as an actual integer, not text. We can do the exact same thing with float for decimals. We can even reverse the process and use the string function to turn a number back into text. You are in complete control of the data.
Okay, before we wrap up, let's establish some essential best practices for clean coding. Always remember that variables must be declared by assigning them a value before you try to use them. Also, Python is highly case-sensitive, so a lowercase a and an uppercase a are completely different variables to the computer. Always intentionally choose the correct data types to save memory, and most importantly, handle user data carefully. Convert it when necessary.
Now, what's really interesting here is the emotional core of programming. Coding isn't some test of perfection. It's a continuously iterative process. First, you think about the logic. Then you code it. You run it to see what happens. It will probably have an error, and honestly, that is totally okay. Then you debug it, and finally you improve it. Embrace this loop. It's how every great programmer out there works.
We've covered the foundation, the nouns, the verbs, the logic, and the conversation. You are no longer staring at a wall of intimidating jargon. You literally have the fundamental building blocks of Python directly in your hands right now. So the only question left for you is this. Now that you have the blocks, what are you going to build? Get out there, start experimenting today, and I'll see you in the next explainer.